Hello everyone, thank you for stopping by. My name is Bino, and in this short video on the application of differentiation, we are given the area of a rectangle as 200 centimeters square. We'll calculate the dimensions required for the perimeter to be at a minimum. We draw our rectangle and we have length, which will be denoted by L, and the breadth will be denoted by B, and our area is equals to 200 centimeters square, and the perimeter is defined as the sum of all the sides. So we have P will be equals to L plus B plus B. We simplify, and this will be equals to L plus L, which is 2L, plus B, which is equals to 2B. And our area is defined as length multiplied by breadth, and we are given the area as 200 centimeters square. So from here, we either make L or B the subject of the formula. So let's instead make L the subject of the formula, and that B will cancel out, and our length will be equals to 200 divided by B. We substitute the L into the formula of the perimeter, so we have P, which will be equals to 2, and in the place of the L we substitute 200 divided by B plus 2B. So our P will be equals to 2 multiplied by 200, which is 400, divided by B plus 2B. In order for us to determine the minimum, we have to differentiate the P, but first we express it as 400 multiplied by B raised to the power negative 1 plus 2B. We had 400 divided by B, and we took the B from the denominator to the numerator, and the exponent changed sign from positive B to negative B. From here, we have to differentiate the P with respect to B. So the derivative of 400 multiplied by B raised to the power negative 1 will be equals to the negative 1 from the B multiplied by the 400, and this will be multiplied by B, and from the exponent of B we have to minus 1, and the derivative of that 2B will be equals to 2. So the derivative of the perimeter with respect to the derivative of the breadth will be equals to negative 400 multiplied by B raised to the power negative 2 plus 2, and from here we have to equate the derivative of the P with respect to B to 0, so that we can get the minimum breadth. So we have 0 is equals to negative 400 multiplied by B raised to the power negative 2 plus 2. We take the positive 2 to the left, and it's changing sign from positive to negative 2, and it will be equals to negative 400 multiplied by B raised to the power negative 2. From here, let's divide both sides of the equation by negative 400, and that negative 400 and that negative 400 will cancel out, and negative 2 divided by negative 400 will be equals to 1 divided by 200, and this will be equals to B raised to the power negative 2. We express the B raised to the power negative 2 as 1 divided by B raised to the power 2. This time around, we took the B raised to the power negative 2 from the numerator to the denominator, and it changed sign from B raised to the power negative 2 to B raised to the power positive 2. From here, we cross multiply, and B squared multiplied by 1 will be equals to B squared. 200 multiplied by 1 will be equals to 200. We solve for b by introducing the square root both sides of the equation. And when we introduce the square root on the right hand side, we also introduce the plus or minus. So the square root and the square will cancel out each other, and b will be equal to plus or minus the square root of 200. We have b is equal to positive the square root of 200, or b will be equal to negative the square root of 200. And this b will be inadmissible because it's a negative. We cannot have a negative length, so this one will be inadmissible. And our b will be equals to the positive 200, and this will be equals to 14,14 centimeters. And now that we determine the value of b, we also have to determine the value of l. And our l is equals to 200 divided by b, and in the place of the b we substitute 14,14, and this will be equals to 14,14 as well. So we have the length and the breadth as 14,14 centimeters.